Today, we have a very special podcast lined up. We're going to be talking and discussing causal AI and AI in general. And we have Ben Steiner joining us today. And so Mr. Steiner is a lecturer at Columbia University. He's serving as the director of the Society of Quantitative Analysts. He's been involved in initiatives including systematic investment techniques, model risk management, and quantitative investment methods, whilst working at BNP Paribas Asset Management and CIT. Additionally, he has served as a consultant for startups and alternative investment funds. So without further ado, we would love to welcome Mr. Steiner. Thank you very much for joining us today.
Anyway, Dylan, thank you very much. It's great to be here.
Thank you. And so, if you don't mind, do you mind just asking what does your current role involve as being director of the Society of Quantitative Analysts and being a lecturer at Columbia University?
Sure. So at Columbia, I teach a number of quantitative courses around risk management, about quantitative techniques, around programming, and actually around strategic communication. One of the things that we find is we can teach the algorithms and the equations, but we need to teach people how to communicate and collaborate as well. And the SQA, the Society of Quantitative Analysts, is the oldest quantitative association in finance, formed in 1965, if my memory serves me correct. It's a not-for-profit, and it exists to enhance the connections between the industry and academia.
Thank you very much.
Yeah, I think it's best that we just get straight into it. So I guess the first question for all our listeners out there, because while a lot of people have heard this term and they've maybe heard some different definitions go around, what is AI? What is artificial intelligence?
Yeah, so artificial intelligence, it's the movement towards doing more with data, with mathematics, with computers, basically to emulate what humans are doing. And there's a number of spectrums of it. If we go back 20 or 30 years, it was basically around the automation of repetitive tasks. So humans did things manually, but a computer can do them in an automated fashion. So that was sort of automation intelligence. And then where we were up until a few years ago was around augmenting the human. So providing tools to the humans to help them do tasks better. And sort of where we might be going, well, yeah, it's a very hot topic at the moment, is towards autonomous intelligence. So where the machines themselves are doing the things without the humans. But essentially, it's been happening for a long time. But it's the use of data. There's more data now. Mathematics and computing, there's more computing power now.
And when you say spectrum, is that within what you've just mentioned regarding augmentation or, assistance-wise, or in terms of within those specific fields, is there a spectrum of abilities of these different sort of intelligence forms to aid humans?
Yeah, I think that's exactly it, which is there's some very simple tasks. 20 years ago, we needed to get things done manually. People would look in a calendar, people would call each other up on the telephone, people would book meetings with each other. Yeah, that sort of stuff now happens because there's tools that allow people to see each other's diaries and book meetings with each other. So that's a very basic example. I focus on the financial markets. So in the financial markets, we have a thing called a limit order. A limit order versus a market order. In the old days, you placed an order and you got whatever price was the prevailing price. So you have to watch the screen. Limit orders have been around for decades, not centuries. And it basically means you don't have to watch the screen. There is something that helps the human get the price they want or get executed at the price they want. So on one level, it's very simple. It's just using computers for what computers should be for. And your generation, it probably seems a little bit almost bizarre. Why would you not use a computer to automate something? That wasn't always the case. But then where we obviously are now, I'm sure you're familiar with ChatGPT and generative AI and large language models. So that's the hot potato at the moment. And there's two schools of thought, which is, this is the beginning of computers that can think for themselves versus, no, they're just still mathematical models that are pattern matching. What I want to make clear is that once upon a time, I was called a quantitative analyst. Then I was called a data scientist, then a machine learning expert. And now we're like AI experts. And our work hasn't really changed, just the power of computing has increased, the volume of data has increased, but the things we're trying to do, which is help make predictions or help explain the past or help support decisions, that's been going on for a long, long time. Maybe one thing that's worth saying is that there's this distinction between narrow AI or AI to support one specific task and general AI or AGI. You may have seen it as artificial general intelligence. We've had narrow intelligence for a very, very long time. Write a computer program to do something is a form of narrow intelligence. Automate something with a macro is a form of narrow intelligence. It's the general intelligence that's sort of the thing that's been out of reach. And that I'm a bit cynical, but some people now think that generative AI will take us there.
And so, if you don't mind going back to what you mentioned earlier, you talked about it's getting rid of almost human activity in many ways, in terms of completing certain tasks and doing certain things. And so, could that be described as a drawback for people in general? And if it is taking away work from humans, what opportunities will there be for positive? Will there be positive opportunities for humans regarding AI?
Yeah, it's a very good question, and a lot of people are very concerned about that. Where we are, the nature of work is changing, and certainly I point out the nature of white collar work is changing. White collar office work, lawyers, bankers, accountants, financial professionals, the type of stuff that I do. The productivity will increase. So the types of things that used to take time will now be done faster. Now, the upside is that means humans can spend more of their time on the higher value added things and less of their time on the lower value add things, booking meetings or making PowerPoint presentations or watching the markets for a certain price to occur. So I think it will certainly have an impact on work. It will certainly make the workforce that you guys are going to be entering after university different to the one that I entered 20 odd years ago, but it already is very different. One thing I'll say that may be hopefully more reassuring than negative is, innovation and change has always happened. This is no different to what we've been here before to a certain extent, maybe not moving so fast, but before computers existed in the 1960s, people had to do mathematical calculations. If either of you have seen that movie about sending the man to the moon, the computers were the people who did the calculations, and that movie is about the women who did the calculations. Of course, when the personal computer was invented, you can't get a job as a computer anymore because the calculations can be done much faster and more accurately inside a machine than in someone's head. So no one has a job as a computer anymore. I remember that was before my lifetime. I remember, like, in my lifetime, when Excel was invented, people would be spreadsheet wizards. Their job was to be the spreadsheet expert in the company. And that almost sounds quaint. Everyone uses spreadsheets these days. You're not going to get a job doing just that. You actually need to know something else. And then the other one I was going to mention was that when Google and Yahoo first came out as search engines, people used to put, I had a good friend who did this, he would put on his resume, I'm a search engine expert. I mean, it sounds ridiculous now, but my point is that as time goes forward, things that are new, people become experts in, and then something else sort of makes that go away. So to your point, where are the opportunities going to be? The opportunities will be in using these new tools.
Okay, perfect. Thank you very much. And then I guess just adding on to that, obviously, since it is artificial intelligence, it's based around technology. For someone like me, so I want to study history further. Dylan wants to study philosophy at university or do law. He changes his mind every week. But how would AI impact us, or how do we get involved in AI if we're not necessarily using technology constantly, if we're looking back at ancient texts and different things like that?
Great question. I mean, I guess, how would you do a research project these days? So say you're doing an assignment or homework, your A-level. Are they still A-levels you guys do, or have they changed?
Yeah, still A-levels.
Okay, I apologize. It's been a few years for me. So you're doing an A-level assignment. What's your first step?
Google.
So I think sort of it'll help you with research. What I would point out is, I want to make a distinction between large language models, which are just sort of one subset of what's going on, and more general models that are something else. But large language models basically are, some people call them stochastic parrots. They basically use a large set of data and they try and sort of predict what's the most sensible word or topic or sentence that comes next. They have problems. They can hallucinate, they can be wrong, they don't have citations. But what they're actually ironically very good at is brainstorming. So you can sort of have a conversation with a large language model about ideas that you have, or give me 5 ideas or 5 topics, or give me some examples of things I might want to do, or I need to write an assignment on this topic. Give me 5 things that might help. Now, I should pause at this point saying, are you actually allowed to use large language models in school? Does the school have a policy yet on using them or not using them? Because at Columbia, we do.
Ooh, I'm not sure. I don't think we do, or nothing explicit.
I think there's an ethical responsibility, especially because a lot of this work we're going to have to reproduce within our exams, unless it's coursework, and even then, that's a very strict monitor. And I think teachers and examiners, they can very much sniff it out right now, especially because some of the students are very bad at using it if they are going to use it. We're not advocating you to do that, but yeah, I think it's not necessarily a written rule yet, but there is an ethical and probably honest responsibility on the student to be. You can use this for inspiration more than anything, but the ideas
definitely no plagiarism.
Yeah.
And the big challenge of these language models is they're unable to cite their sources. So they basically have sensible sounding text that may be complete gibberish. It may be completely made up. It may be factually incorrect. So the message is, if you are going to play with these things, don't rely on them to be factually correct. And so actually they're better for creative endeavors, writing songs, brainstorming, summarizing information, rather than actually retrieving facts.
I actually find it quite interesting because we got given an article which was 63 pages in politics, and it was regarding an ideology, and this is an ideology stemming back from the 1700s. So I actually used one of these models to summarize it more than anything. But I think the most important thing for students out there is have a go at it first as well. That's a really important thing that I've learned when sort of interacting with these models, is sort of even though it can summarize and maybe point out some key angles of the article and provide some creative endeavors off the ideas that you get off the article, something that I've noticed and actually makes me work better is have a go first yourself, sort of figure out your own areas, because then you can also implement those ideas into the models to help you sort of branch out your own sort of paths and academic endeavors sort of. So that's a tip I would have for our listeners out there. And I think building on that point is, should we be concerned regarding the ethics of AI, such as bias or privacy concerns, but also the ethical implications of building such models?
Absolutely. I mean, let's maybe jump from there's the ethics of claiming the work is yours when it's not yours. There's the ethics of the model is using source data to learn from, but is not giving credit to that. So moving now away from language models just to more general ideas. Yeah, I mean, there's bias. So basically, some of the areas that I've worked in are models that give loans to people, that approve people for loans. And if there's bias in the training data, there will be bias in the output of any model. So training, thank you for telling me your history and philosophy. Training data is the data you show the model. That's what we call the sort of data the model can learn from. And then out of sample is making a prediction on something. So for example, if a bank is giving out loans for mortgages, they will have a huge set of data that will show the characteristics of the borrowers and whether they repaid their mortgages or not. And then when a new borrower turns up, they'll effectively compare them to the borrowers they've seen in the past to decide, yes, they should automatically give them a loan, no, they should automatically decline the loan, or they should refer it to a human to investigate in more details. So if the training data itself has bias, if people living in a certain area were all denied loans, if people of a certain gender or race or age were all denied loans, what that means is the model will learn from that biased training data. And so it's not the model itself at fault. It's the setup of the model and the data that was being used. So yeah, there's ethics around bias is huge. There's also concern around how models can explain themselves. So a model shouldn't just produce an output. A model should also explain why it created that output. Because if a human can't audit a model, bad things can happen.
Yeah. And I think,
Yeah, go.
sorry, I don't know. I was just remembering there's this case study, I think, done by Reuters about Amazon. I think it was in 2018. And what it found out was that they were using an AI algorithm for employing people in, I think, in 2015. And it turned out to be sexist because it realized it was building up on data built through previous applicants where majority of people were male. And so the AI model learned that more successful applicants were male, therefore we should favor more males. And I think, correct me if I'm wrong, but I think that was another example of what you just talked about, bias within AI.
100%.
Yeah.
If the training data itself has an issue, a model is just going to repeat what it's seen.
Yeah, and I think that's also one of the key strengths of humanity, regarding what we sort of talk about when you're talking about humans versus AI. One of the key strengths I think we always have is that we can be accountable to ourselves in terms of our methods regarding a procedure that we take towards reaching a certain goal. And sometimes AI, if that doesn't have that, I think, like you said, it has really bad consequences. So when we are, I don't know, my whole vision when we're designing these AI tools and everything is that you would have funny enough, the philosophers, the historians to talk about, the history of when you deny or when you sort of remove aside certain beliefs, or the philosophers to talk about the ethical implications, not just the people who are technically the most gifted to be able to deliver these tools. I feel like that's quite an interesting angle to point it at.
I'll agree with you, and I'll give you sort of one step further, which is if we build models that are the most accurate, we'll get the most accurate models. But they will have bias and fairness and concerns within them. So what we need to do is build models, in some cases, not in every case, in some cases, that have normative values built into them. So there's something called an objective function. And the objective function in a model is basically the thing that says, try to minimize the error between what I'm predicting and what actually came out in the training data. Now, historically, because it's been the data scientists and the computer scientists, accuracy has been the primary guiding light. Make the most accurate model, minimize the error between what you're predicting and the actual result. Where the philosophers come in is in saying, get a good enough accuracy, but also ensure the models are fair, ensure the models are unbiased. And what that happens in some cases is actually imposing normative values on the training data we've seen historically. So yes, I'd agree with you completely. There is a role for philosophers in this work.
Yay. Yay.
So I think we've touched on what seems to be quite a big problem within AI, and that's the whole area of ethics surrounding bias that it can produce and the need for philosophers. So with that, hopefully we can drift more into what you do, and that's causal AI. And just to introduce it, before I hopefully ask you what is causal AI, there's Pearl, who is the founder or is seen as the father of probabilistic reasoning, said that in order to build truly intelligent machines, teach them cause and effect. So I was hoping that you could please expand on this and hopefully expand on what causal AI is.
Sure. So let me start with what is causality. So cause and effect is when changing one thing causes an effect in something else. So there's like something happens, then something else happens. There's like a direction to it. The second thing is listening to the first thing and then responds to it. Now, most machine learning doesn't understand that concept. Most machine learning uses correlation, and just to make it, correlation is the measure of association. Two things go up and down, they're correlated together. If one thing zigs when something else zags, like one goes up, something else goes down, they're negatively correlated. So most machine learning works on pattern matching. It finds relationships in the data. So if A is correlated with B, it doesn't know if A causes B, if B causes A, or if C causes A and B. So just because two things are correlated, we don't know anything about cause and effect. There's a famous thing, correlation is not causation. You may have come across this in philosophy or in history. Correlation is not causation. Just because two things happen at the same time, you can't really comment on it. And so a lot of bad things have happened over the years because people have made that mistake. So causal AI and causal techniques tries to overcome that. So it introduces this idea that there's a direction, that A leads to B, or A doesn't lead to B, and we can't say anything about it. That, in a nutshell, is what the causal techniques and causal modeling is all about. And what I would point out, it's not just Perl. Perl has come up with a lot of the sort of techniques that are used, but there's a whole variety of techniques within this that predated Perl, that grew up in parallel to him. And it's not just a single algorithm or a single tool set. There's multiple techniques. Some of them compete with each other. Some of them are better on certain types of problems. And so one of the really important things is understanding the assumptions and limitations of each technique, and as always, using the right tool for the job.
So let me get it. So it's basically trying to remove that idea that correlation equals causation, and trying to make sure that we are getting the most accurate sort of reading of those sets of data and sets of ideas that are happening at the same time using those techniques.
So it's about breaking the link. Correlation is symmetrical.
Right.
Causal has this concept of a direction. It's not just about accuracy of models, though. It's also about going beyond just making a blind prediction.
Oh, okay.
Certainly the Perl's work, Judea Perl's work, encompasses what we call causal graphs. And a causal graph is essentially a map of a computer model or mathematical model. So if you imagine circles and lines, the inputs are on one side, the outputs are on the other side, and there's a network diagram with lines connecting them to each other. And because it's visual, it's very explainable. And it allows a number of things to be done that then can't be done with more conventional machine learning based on correlation.
Perfect. So I think the next question regarding causal AI is, what are some of like in real life applications of causal AI as well as the limitations of them?
Sure. So where it really comes into its own is when we want to ask questions of a system about explaining how much of something was caused by something else, or attributing how much of something was really because of something else. And the final one is imagining what might happen if something happens. We call that a counterfactual. So using this causal diagram that's been built to ask what would happen if ... So to give you an example, things like when it comes to healthcare and preventing a disease, how effective a certain treatment is in preventing a disease, or in agriculture, what is the impact of each variable on a certain crop? So chemicals and compounds and temperature and soil and so on and so on. There's a field called precision agriculture that's really about monitoring and understanding what's driving the crop yields. Or for an individual company, if they increase their sales last year, everyone will have a different reason for thinking they increased the sales. The product development people will say it's because we had a better product mix. The marketing department might say it's because we had a new marketing campaign. But maybe something happened last year, like the government gave a tax break to consumers, so they had more money in their pocket. So that's why they bought more of it. So it helps try and disentangle things that were hard to disentangle in the past when it was just correlation.
And so with that, how would you ensure that what it is distangling is it's doing its job effectively and also ethically as well?
So that's where there's two branches. There's a branch that's data-driven only. There's a branch that tries to learn these causal effects, or what we call causal discovery, using just data and data alone. There's another branch that brings in the human, and the causal graph, or this network of how things vary with each other, is defined by a domain expert. So to answer your question, the way to ascertain is it doing its job properly? Is it doing the right things? Is depending on how much data there is, and depending on how much human knowledge there is about the domain being modeled, will determine how much data or human knowledge gets combined. And then for any model that we built, we can always look at the accuracy. There's a lot of mathematical techniques, R squared, root mean squared errors, loss functions, that measure, is the model accurate if it's predicting something? However, the real value of these causal approaches is about explaining and attributing the model output, not just making a prediction. And then the question then is, how do you tell if a model is explaining itself? And there's a checklist that we go through. The first one is, does the model give an explanation as well as give an output? So basic models just make a prediction. Black box, here's a number. What we really want is the number that comes out plus some kind of explanation. That's sort of level one. Level two is, does the explanation come out have some kind of meaning to the model user? So, if the answer is 3.6, that kind of means nothing without context. So the idea is a non-technical person who's using the model should get some insight about the model output from the explanation. Then there's a third level, which is demonstrating that the explanation itself is accurate. There's various techniques to do that, but the idea is it should both be understandable to the human and accurate. And the final level when it comes to explainability is that if a model can't explain itself sufficiently, we have a concept called an uncertainty interval. So rather than me saying, Dylan, you're 5'10", I might say, I can only see your head on this Zoom. You're somewhere between 5'6" and 6'2". So my uncertainty on how tall you are grows because of the information I have. So the highest level of model explainability is where the output of the model becomes a function of the uncertainty, and the uncertainty is a function of the accuracy of the explainability. Now, just to be clear, this isn't done in most cases. This is sort of where the industry and where the practice is going.
Yeah, so I see the potential for, I guess ethically, the terms are, the accountability that it can give, and the precision, the fairness, and all of that. And that's actually really promising to hear that. That there is these stage processes regarding the result that's given, and I think that's a great point to sort of hammer on for our listeners.